Okay, let me give you guys some more examples. But before I do, just a quick reminder from our section on inequalities. If you have a circle with a blank, well, if you have a blank circle here, it means it doesn't include the negative two. And then if you have a filled up circle here, then it means it does include the one. So for you to have a range here, you see this is strict x here is strictly greater than negative 2. It it cannot be a negative 2. It doesn't include the negative 2, whereas here it includes the 1 here. Okay, just a quick reminder. Well, here some more examples for you. Suppose you have a function here like this. So here you've got a function. Let's just call it f of x here. Now let's say f of x here, it travels like this, goes up to infinity, and then from infinity it goes down, and then at this point here, and then this up until here, it doesn't include the negative 4. So when f of negative 4 here, then you have to jump to this bit here, because remember from up here, if this here doesn't include the negative 2, whereas this one here it includes the whatever's here. Okay, well, when you see a diagram like this here means yeah, the f of negative 4 in this case would be 5 here. Okay, because this bit here it doesn't include it doesn't include this spot here. Well, anyway, then the function continues to do this here, and then, well, so here f of positive 3 is 7. Okay, not 6, not this bit here, and then here there's a gap. Okay, there's a gap in between, and then it goes up to infinity, and then from minus infinity here it will travel back down here. Well, anyway, this is just a made up function, so I'm just going to give you lots of examples here. So now the limit, so here's the first example, the limit of f of x here as x tends to negative 9. So here what this means here is that you are here, you've got to travel all, as you're traveling to the right here, you're heading towards infinity. Okay, so here it's infinity, and then don't forget you have to take from the left direction and then also from the right direction. So here from the right direction, so you're here, you're traveling towards negative 9 here. Now you can see you're heading towards positive infinity. Now because they're traveling to the same place, you can say here the limit is infinity. Okay, here's another example. Let's say the limit of x as x tends to, let's say, negative 7. So that's this bit here. Okay, so the limit of f of x here as x tends to negative 7. So here you've got to travel from the left. So heading from the left hand side, you're heading towards the number 4 here. Okay, and then you've got to consider the right hand side. Well, the right hand side, you're also heading towards the 4 here. So the limit here is 4. You've got to consider from the left hand side and also from the right hand side. If they meet at the same place, then the limit exists. Okay, in this case is 4. Now look at this case here. Limit of f of x here as x tends to, let's say, negative 4 here, as x tends to negative 4. So you've got to consider the left hand side. So you're approaching negative 4 from the left hand side. So here you're approaching positive 8. Okay, from the left hand side you're approaching positive 8, but then from the right hand side you're approaching positive 5. Now, in order for the limit to exist, they both have to head towards the same point. Here you've got a point where you've got positive 8 and then a negative 5 here. So here the limit does not exist. So you have to say limit f of x here as x tends to negative 4. well, you had to say does not exist. Okay, the limit does not exist. Okay, and then here another example here. The limit, let's say the limit of f of x here as x tends to, let's say, positive 3. You see here the limit does not exist because look, from the left hand side you're heading towards 7, and then you've also got to consider from the right hand side here the limit is 6, so therefore the limit doesn't exist for 3. Okay, and now so here another example, limit of f of x as x tends to positive 6. Now here, even though there's a gap here, well, heading from the left hand side, you're approaching a limit of 4, and considering the right hand side, you are also approaching 4. Even though there's a gap in between at 6, you can still say the limit exists. Okay, limit of f of x as x tends to positive 6 equals 4. Okay, I know even though there's a gap here, you can still have a limit even though there's a gap. Okay, so now the limit, last example, limit of f of x here as x tends to let's say 9 here. 9 here. Here, if you're traveling from the left, if you're coming from the left, then you're going to head towards positive infinity. Now, from the right hand side, here, traveling towards positive 9, you're heading towards negative infinity. So here, the limit does not exist. But however, you can do this. You can do this. You could say the limit from the left hand side. When you stick a minus here, it means a limit from the left hand side here. You can actually say infinity. Or you could do this here. Hang on. Or you could do this. You could say the limit from the positive direction, from the right hand side here, you could say negative infinity, because here from the right hand side you're heading towards negative infinity. But if you don't have a sign here, it means, well, here then the limit does not exist, because they're two different they're heading towards two different places really. So but just bear in mind that you can do this negative here when you're considering only from the negative side. You can say this, okay? But then, well, I hope you get the idea, okay?